In this video, we're going to be looking at taking notes for Lesson G on the multiplication counting principle. You should have these notes in front of you and take them as we go. So counting is a very simple everyday task, but there are many counting problems which will require more advanced strategies. Say you want to order a pizza from a local pizzeria. How many different types of one-topping pizza can you choose if you have 2 options for crust, 3 options for sauce, and 8 different options for toppings? Now you're only choosing one of these options in each of those categories. So we could look at this problem using a tree diagram. In a tree diagram, you make a branch for every option. So the 2 different options for crust where you'd start would look like this, maybe like that. And then over here, so these are the crust options, 1 and 2. And then for each crust option, you could choose 3 different options for sauce. So 1, 2, 3, 1, 2, 3 there. And then for each of these crust and sauce options, you're going to choose one of the 8 different toppings. So there would be 8 toppings to choose from, so 8 different branches come off of these branches. 1, 2, 3, 4, 5, 6, 7, 8. Four, 5, 6, 7, 8. And finally, 4, 5, 6, 7, 8. So there were the resulting number of branches is how many different pizza options there are. So each of these ends of branches has 8 branches on them, and there are 6 of them. So you could take 6 times 8, or find out there were 48 different possible pizza combinations. Now, we could also do this a little bit more simply by using the multiplication counting principle, in which we would say there were 2 different options for crusts, 3 different options for sauces, and 8 different options for individual toppings, and 2 times 3 times 8 is 48. Saved us a little bit of time, and that's the basis of our multiplication counting principle. You can see here that the multiplication counting principle says that if there are n sub 1 ways of choosing the first item, n sub 2 ways of choosing the second item after the first item is chosen, n sub 3 ways of choosing the third item after the first 2 have been chosen, and so on until there are n sub k ways of choosing the last item after the earlier choices, then the total number of choices overall is given by the formula n sub 1 times n sub 2 times n sub 3 all the way out to n sub k. You just multiply them. Let's look at this in example 1. Scroll this up. Example 1 says, a chain restaurant has a 3 for me deal. That allows you to pick your beverage, appetizer, and main course starting at $10.99. They have 11 beverage options, 13 main course options, and 13 appetizer options that go with this offer. How many different 3 for me deal orders are possible? Well, if we use the multiplication counting principle, we would simply take 11 times 13 main course, and then times 13 appetizers. If you multiply that out on your calculator, you get 1,859 different options. That's a lot of options. Let's try another. In example 2 here, it says that the SKU number for box cakes mixes are a 9-digit code, where the first 3 numbers are 705. That doesn't change. Then the middle 4 numbers can be any digit except 0, and the last 3 numbers cannot repeat. but for those last 3 spots only. How many different possible codes exist? Well, so let's see, it's a 9-digit code. So we're going to have 9 things potentially that we're looking at. 1, 2, 3. Is that? That's actually 10. So this should say 10. It's a 10-digit code because there are 3 and then 4 and then 3 more. So I think 1 more. Yeah. So the first 3 digits are fixed. These don't change. They are always 705. So there's only one option for those. We don't have to multiply that together. The middle 4 digits can be any digit except 0. So that's these here. 1, 2, 3, 4. Now the digits go from 0 to 1 to 2 to 3 all the way out to 9. So in total there are 9 plus the 0, so 10 digits possible. But the middle 4 can be any digit except 0. So that's only the digits 1 through 9. So for our middle 4 positions here, we can choose from 9 different digits. And we would multiply them together using our multiplication counting principle. Now, the last 3 digits, the numbers cannot repeat. So from our 10 digits that we have possible, 0 through 9, there were 10 possible numbers you could choose for this first place. But then once you chose the number, say 8, you could no longer use the 8. So now you'd have 9 digits left to choose from there, and then 8 digits left to choose from for your last digit of your SKU number. Multiplying these all together, we are going to get 4,723,920 different possible SKU numbers for cakes, for boxed cakes mixes. And that would be our answer for number 2. Seems kind of high. Let's look at example 3. The talent show at a local elementary school has 4 musical acts and 5 comedy skits. How many orders in the program are possible if the host wants to alternate between musical acts and comedy skits for the whole program? Well, since there are 5 comedy skits and 4 musical acts, if you want to alternate, you've got to start with the comedy skits. So let's do these in different colors. Let's make comedy purple. 1, 2, 3, 4. There are 5 comedy acts. Let's leave a space there. I'm just leaving spacers here for what we're going to multiply because we're using our multiplication counting principle. And then there are 4 musical numbers, so we'll do those in blue that we will choose from in between here. Now, for our 5 comedy skits, for the first number, there would be 5 to choose from. But once you've chosen one of your comedy skits, there would only be 4 to put here. And then once you've chosen the first 2, there would only be 3 for the next spot you're going to put a comedy skit in. And likewise, 2 and 1. Now, for your musical numbers, you have 4 to choose from for the first one. And then after you've chosen that one, there would be 3. Beyond that, 2. And finally, the last one would go here. Multiplying all of those numbers together, we're going to get 2,880 different possible program orders for these skits at the talent show. Anyway, I hope that gave you a good example of some multiplication counting principle problems, and we'll see you in the next video. Thanks for watching.